Good morning, students. We will continue with Chapter Magnetism, Part 2. It is Video 4 for the Class 6 of Subject Physics. Topic is Magnetic Field around a Magnet. Magnet, we know it attracts iron, cobalt, and many other magnetic material without coming in contact with them. From distance, it attracts magnetic material toward it. That force which attracts magnetic material toward the magnet, that is magnetic force or magnetism, and we call such force as non-contact force. Non-contact force. A magnetic field is an invisible area of magnetism around a magnet, and magnetic field is stronger near the pole. And if we draw the pattern of magnetic field lines from this pole, magnetic field develop and join like this toward other pole. Similarly, like this. Magnetic field line follow a pattern but never intersect each other. One of the most amazing property of magnet is the way it attracts iron and other magnetic material without any contact or from a distance. Then a magnetic field is an invisible area of magnetism around a magnet. So this definition you have to underline: a magnetic field is an invisible area of a magnetism around a magnet. Magnetic field lines have the property. Which property these lines have? That magnetic field is the strongest near two poles of a magnet. Second, magnetic field line follow a pattern and never intersect each other. Then, activity to recognize magnetic field around a magnet. In this activity, we will take a magnet on a cardboard and gently sprinkle iron filling on the cardboard. The iron filling will arrange themselves in a pattern like this. This pattern shows that magnetic field line around a magnet, and these lines represent the magnetic field of a magnet and shows the strength of a magnet at various positions. Then we come to know that magnetic field converge near the two poles of a magnet. This signifies that magnetic field of a magnet is strongest at the poles. And this property 4 or 5 times we had read. This is activity 5, to recognize magnetic field around a magnet. Okay, this activity you have to read. Already I explained. Earth's magnetic field. Earth, it has huge magnetic field around itself and acts like a magnet. At the center of the earth is the solid inner core. That solid inner core is made up of iron. Solid iron. Surrounding this solid iron core, hot, liquid, molten iron, forming the outer core. Constant spinning of the earth around its axis create electric current. When it creates electric current, molten iron core, which in turn produce magnetic field around the earth. Constant spinning of the earth around its axis create electric current in this molten iron core, which in turn produce magnetic field around the earth. Earth magnetic field is produced by shifting motion of molten iron in the earth outer core. Earth's magnetic field, also called geomagnetic field. What we call it? Geomagnetic field. Geomagnetic field. Extend to several thousands of kilometers into space. Such a powerful geomagnetic field is developed by the earth. Earth magnetic field or geomagnetic field is similar like the bar magnet. Like bar magnet, this one. This is the shape of bar magnet, and we know bar magnet, around it how magnetic field lines are developed. If we imagine that a big bar magnet buried deep inside the earth and axis tilted at about 11 degrees Celsius from the spinning axis of the earth, then one property of magnet we know that if we suspend a bar magnet freely with the thread, then it always suspended toward north and south direction. And another property of magnet we know, opposite poles attract each other. Then here south pole and another side north pole will develop. If we imagine, then this side of the earth we have earth magnetic south pole. If you imagine a big bar magnet present inside or buried under the earth, then this side Earth magnetic south pole is developed, which attract north pole of the magnet. Geographically we know it is north pole, and another side we have south pole. Imagination this about this bar magnet. Another side of the bar magnet where north pole I have written on the bar magnet, which magnetic pole will be developed? Then Earth magnetic north pole. Then the condition of the Earth we will write like this: due to the attraction of north pole of magnet toward the geographical north pole of the Earth. It is geographical north pole of the Earth, and north pole of magnet it attract toward geographical north pole of Earth. But if we imagine that big bar magnet is there, then south pole toward the north it act like Earth's magnetic south pole, and north pole toward the south it act like Earth's magnetic north pole. That's why when we suspend a magnetic or bar magnet freely, it always point toward north and south direction of the Earth. See in the book, an important property of Earth is that it has huge magnetic field around itself and hence act like a magnet. Underline has a huge magnetic field around itself. Underline it, has huge magnetic field around it. Second point, at the center of the Earth is a solid inner core. Underline, it is made up of solid iron. Surrounding this solid iron is hot liquid molten iron. Hot liquid molten iron forming the outer core. Third point, constant spinning of the Earth around its axis create electric current in this molten iron core. Where electric current is creates in molten iron core, which in turn produce a magnetic field around the Earth. Next point, Earth's magnetic field is produced by the swirling motion of molten iron in the Earth's outer core. Clear these points already through diagram. I explained all this. Earth magnetic field also called geomagnetic field. Underline this, geomagnetic field. Extend to several thousands of kilometers into space. Earth magnetic field or geomagnetic field is similar to that of a bar magnet. Imagine that Earth has a giant bar magnet buried deep inside it with its axis tilted at 11 degrees Celsius from the spinning axis of the Earth. The north pole of this magnet act like Earth magnetic north pole, and south pole of this magnet act like Earth magnetic south pole. Earth has two geographical poles by convention, geographical north pole and geographical south pole. Earth magnetic north pole is closer toward geographical south pole. In diagram it is clear. Earth magnetic south pole is closer toward geographical north pole. Freely suspended bar magnet always align itself toward geographical north and south pole. This is because the north pole of bar magnet is attracted toward the magnetic south pole. Opposite magnetic poles attract, we know. Hence a freely suspended bar magnet always rests in geographic north-south direction corresponding to the geomagnetic south-north direction. Need not to get confused, already I explained these diagrams which are representing where geographical north pole, where geographical south pole, and why we call this one as earth magnetic south pole and why we call this side as a earth magnetic north pole. Okay, clear? Making of magnet. How we can change soft iron pieces in form of magnet for temporary purpose or for the permanent purpose. We will read this thing in this topic. Magnetic material like an iron clip or a needle can be made to exhibit the properties of a magnet or behave like a magnet by a process called magnetization. Next, the magnetic material that can be magnetized are iron, cobalt, nickel and their alloy. In first video I explained what is an alloy. Non-magnetic material cannot be magnetized. And what is non-magnetic material? That material which are not attracted by a magnet. Various methods we use to change magnetic material in form of magnet. The methods are induction method, stroke method, electrical method. Induction method by keeping the magnetic material close to a magnet. Stroke method by rubbing a magnet over a magnetic material. Rubbing. Then electrical method by passing electric current underline around a magnetic material. First we will go through induction method. Induction method, see this diagram, bar magnet they have kept, and iron clips get magnetized by induction method without touching. So this method involves placing magnetic material close to the strong magnet without touching. Soft iron bar becomes an induced in magnet. Soft iron bar becomes an induced magnet with the end nearer the magnet, having opposite polarity to the magnet. Induced magnetism is a temporary process. Which process? Temporary. If the permanent magnet is removed, the magnetic material will lose its induced magnetism. This method is induction method. We have this magnet. So see what is induction method. See this one. It is touching. Now without touching, see, it act like magnet. This needle act like a magnet due to induction. See, needle is not touched with magnet. Clear now what is induction method? It is a temporary. When I remove this magnet from here, then you can see the condition of this. Simple needle it is. And when once again I take it closer to the magnet, see in which way it get magnetized. stroke method. It's a very simple way to magnetize a piece of iron or magnetic material is by rubbing a magnet over the iron bar from one end to the another repeatedly, and in activity it is given. In this activity they have shown how we can make a magnet by using stroke method. We will take a bar magnet and we will place over the tabletop. Now one end of the bar magnet, maybe north, maybe south, your choice, and rub along the length of the iron bar. We will repeat this one 40 times in same direction, not like this, in same direction with the same pole. Pole remains same. If it is north, then continuously with the north we will rub it. If we will take south, then with the south we will repeat in same direction 40 times. In the diagram they have given A point and B point. So strokes start from A to B, then again we will pick it up, again we will touch at A, then B, like this. Then what we will observe, that the two ends repel each other. If we bring bar magnet near this magnet which we magnetized by stroke method, then same pole will repel and like pole attract each other. Stroke method. I have one soft iron piece, this needle. Now I will rub this magnet same pole for 40 times. Now we will check, it is softer one, so we will check that magnetic field is developed. See, for temporary we prepare or convert this soft iron needle in form of magnet by stroke method. Next method, electrical method. This is another way to change soft iron pieces in form of magnet. So in this method we will take once again soft iron bar is by, we will convert soft iron bar by passing electric current through coil wrapped around the soft iron. Okay, so such magnet is known as electromagnet, and electromagnet may be of any shape and size. See the diagram. Soft iron bar, coil copper wire, it is connected with battery and switch. To make soft iron bar in form of magnet, what we have done, we will cover this soft iron bar with wires of copper. In several turns we will cover soft iron bar with the copper wire. Now we connect copper wire to the battery and pass current through the coil. then we will observe that this soft iron bar, it acts strongly like a magnet, and when we bring any iron or magnetic material near it, it will attract strongly toward it. One end of this iron bar is north and the other end is south pole. If we reverse the direction of electric current, poles also get reversed. And if we turn off the current in the coil, iron bar loses nearly all its magnetism, and magnetism is an electromagnet, can be switched on or off according to the requirement. Test yourself on page number 78. Magnets attract dash substance. Which substance? Magnetic substance. Magnetic substance. Dash is a natural magnet while bar magnet is dash. Magnetite is a natural magnet while bar magnet is a artificial magnet. A freely suspended rest in a dash direction. North, south direction. A magnet always has dash poles. 2 poles. Dash poles attract and dash poles repel each other. Unlike poles attract and like poles repel each other. Up to this, you have to revise the full chapter, and I will give you 2-3 questions you have to practice. First question, what are properties of magnetic field lines? Second question, what is magnetization? Third question, what are magnetic substances? Revise full chapter and practice these 3 questions. Next topic we will discuss in next video. Thank you.